Viewers, welcome to CMO Online Mathematics class. Today we are going to look at conversion of decimal number base to base 10. I'm having an example here on the board which says convert 101.0112 to base 10. So let's go. We're going to take the solution for this 101.0112 to base 10. If you look at this, there's a decimal point here. That is the essence of the topic we are looking at today, which is what? Conversion of decimal number base to base 10. But in our previous lesson, we did conversion of other base to base 10. So for us to do this, still the same method, but the only difference is just that we are going to have a negative power in doing this, in solving this. So let's go. The first one, pick out the first number here, which is what? 1 times our base 2. Count the number of digits remaining. That is, you are working on the numbers after before your decimal point. And you can see that we have 3-digit number here, 101. So we are going to work on this first before we work on this. The numbers on our left hand side before we go to the numbers on our right hand side. So for us to get the number on our left hand side, which is our positive integers, we are going to bring out the first number here times our power, our base. Then for us to get our power, count the number of digits remaining, which is what? 1, 2. So raised to power 2 plus 0 times your base raised to power 1. Remember I told you earlier that once you have gotten your first power, it's moving in descending order. So now till we get to 0. So we'll go to the next one, plus 1 times 2 raised to power 0. Then plus, look at this now, there's a decimal point here. For us to get this now, we are going to do the same thing, but the only difference is that our power is going to go in ascending order. Just like the ones on our left hand side, our power is moving on descending order till we get to 0. But the values on our right hand side is going to move from ascending order, but with a negative sign. So we have this now with what? 0 times your power. You count how many. We are starting with minus 1 because we have 3 numbers here, 1, 2, 3. So it's going to be minus 1, minus 2, minus 3, minus 4, depending on the numbers of integers you have in that question. So we have this plus 1 times 2 raised to power minus 2 times 1 plus 2 and times 2 raised to power minus 3. So now we come down and say 1 times 2 raised to power 2 will give us 4. Plus 2 raised to power 1 will give us what? 1. 2 times raised to power 1 times 0 will give us what? 0. Plus anything raised to power, put down a 1. Anything raised to power 0 will give us what? If you look at it, multiply by 0 here, will give us 0. So I'm going to put my 0 down first. Plus 1 times, there's a minus sign here, so this minus sign is representing what? 1 all over 2 raised to power 2. This is the same thing as saying in indices, you're applying the law of indices, which says that a raised to power minus n is equal to 1 all over a raised to power n. So we're applying this law of indices into this part. Wherever you see minus here, we are putting what? 1. Then you bring your power and your base and your power. The same thing applies here. So that's why we're having 1 here. Then you have your plus 1 times 1 all over, that is this minus here is representing 1, 2 raised to power 3. So 4 times 1 will give us what? 4. Plus 0 plus 1 times 1 will give us what? 1. Plus 0 plus 1 times 1 will give us what? 1. So I'm going to say 1 all over 2 raised to power 2 will give us what? 4. Plus 1 times 1 will give us what? 1. 2 raised to power 3 will give us what? 8. So now add 4 plus 1 will give us what? 5. Plus 1 all over 4 plus 1 all over 8. You can see that this is the fraction. So we are going to look for the LCM for this. So let's look for the LCM for 8 and 4 will give us what? 8. 8 divided by 4 will give us what? 2. 2 times 1 will give us what? 2. Plus 8 divided by 8 will give us what? 1. 1 times 1 will give us what? 1. So 2 plus 1 will give us what? 3 all over 8. So we have done the fractional part first. This is the whole number part. So number part, which is 5, Then bring the fractional part. The answer I got for the fractional part, which is what? 3 all over 8. So I'll bring my 5. 3 divided by 8 will give us 0.378. So now I'm going to remove this 0 point because it's of no need. So I'm going to put my 0.378. So I'm saying therefore 101.0112 is equal to 5.378 to base 10. So that is my answer. Then we'll go to example 2. We are going to take example 2. Example 2. Convert 1.238 in base 10. The same thing applies here. We are going to, first and foremost, we are going to solve for the ones in our left hand side before we go for the ones in our right hand side using the same base, which is what? So we are going to look at example 2. Express 241.238 in base 10. So let's go like this. We are going to say equals to 2 times your base raised to power count 1, 2 raised to power 2 plus 4 times your base raised to power 1. It's moving in descending order. Plus 1 times your base raised to power 0. So now we go to the values in our right hand side. Plus 2 times 8 raised to power minus 1. Remember I said it's moving in ascending order. Once you have finished solving the one in your right hand side, your left hand side, as you are solving for your right hand side, your power is going to move from in ascending order but with a negative sign. So you have this 2 times 8 raised to power minus 1. Then we'll go to the next number there, which is plus 3 times 8 raised to power what? Minus 2. That is how it keeps on going as long as you have as many numbers as possible. You keep on going. So now the next one we are going to do now, we're going to say 2 times 8 raised to power 2 is 8 times 8 to give us what? 64. Plus 4 times 8 raised to power 1 will give us what? 8. Plus 1 times 8 raised to power 0 will give us what? 1. Plus 2 times, remember there's a minus sign which represents what? 1 all over 8 raised to the power of 1, which is same thing as 8. But let me just put the 1 there. Plus 3 times this minus is representing 1 all over what? 8 raised to the power 2. So we have this 2 times 64. 2 times 64. 64 times 2, 4 times 2 give you 8, 6 times 2 give you what? 12. So we have what? 128. So that has 128 plus 4 times 8 will give us 32. Plus 1 times 1 will give us what? 1. Plus 2 times 1 all over 8. So 2 times 1 over 8 will give us 2, but let's go step by step. Plus 3 times 1 all over 8 times 8 will give us what? 64. So now I'm going to go down. 128 plus 32 plus 1 plus 2 times 1 will give us what? 2 all over 8 plus 3 times 1 will give us what? 3 all over 64. So I'm going to add 128 plus 32 plus 1. We give 1. 161 plus 2 all over 8 plus 3 all over 64. So you can see that this is also a fraction. So we are going to look for the LCM. So our LCM is what? 64. So 64 divided by 8. We give 64 divided by 8. Divided by 8 will give us 8. And you pause that one. So 64 divided by 8 times 2 will give us 8 times 2 will give us what? 16. Plus 64 divided by 4 will give us what? 1. 1 times 3 give us what? 3, which was 16 plus 3 give us what? 19 all over 64. So this is the fractional part for this fraction. So I'm going to bring the whole number part, which is 161 plus 19 all over 64. 161, bring your 19 all over 64. You are bringing the whole part and the fractional part together. So now we are going to divide the fractional part, which is 161, 19 divided by 64. 19 divided by 0.2968. So approximately 0.29. Take 1 from 8 and add to 6 to give you what? 7. So remember, when you are solving that of the decimal numbers in number base, you are not putting the 0 point. So take the whole number part there. So I'm going to put my decimal point 0.297 to base 10. So I'll say therefore 241.238 is equals to 161.297 to base 10. So that is it. So this is our answer.